Next, we are to discuss polar form of complex numbers. So first of all, we have the complex number z is equal to a plus bi. We are to plot this one. So again, we have our horizontal and vertical axis. We have the horizontal is the real part, and the vertical is the imaginary part. So again, we have this line segment. This is the absolute value of z, or the modulus. And this is B, and this is A. So the imaginary part and the real part, and this is our angle theta, or the argument. So how do we have? So we have the value of z is the same as the r, or the modulus. So we can have the sine of theta is equal to opposite. That is B. Our hypotenuse is r. We can have the value of B equal to r sine of theta. Then we can have cosine of theta, that is the adjacent side A. Your hypotenuse is the modulus r. We can have the value of A equal to r cosine of theta. So initially we have, from the rectangular form of a complex number z is equal to a plus bi. We are to substitute. We have now the complex number in the polar form. Is the value of a, that is r cosine of theta plus equivalent of b, that is we have r sine of theta multiplied by I. If you have to factor out r, this is going to equal to r multiplied by the cosine of theta plus I sine of theta. So this is the polar form of a complex number. So example. So let's have examples converting a rectangular form of a complex number to a polar form. So let's have this first example. We have the complex number z is equal to 3 plus 4i. If we are to plot that, this complex number lies on quadrant number 1. So we have the value of b on the imaginary part is 4. The value of a on the real part is 3. We are to compute for the absolute value, or the modulus. That is r is equal to the square root of a squared plus b squared. We have r is equal to the square root of we have 3 squared plus 4 squared. This is obviously equal to 5. That is the absolute value of z. Then we are to compute for the argument. We have theta, that is the tangent of theta is equal to opposite, that is b over a. This is the tangent of theta is equal to 4 over 3, and the value of theta is now equal to, this is 53.13 degrees. So our equation for the polar form, that is z is equal to r multiplied by the cosine of theta plus I, the sine of theta. So we have the value of z is equal to r, that is we have 5 multiplied by the quantity. This is cosine of theta, this is 53.13 degrees plus I the sine of 53.13 degrees. So this will be the polar form of this rectangular this complex number in the rectangular form. So that will be our answer. So let's have another example. For example, I convert to polar form. The complex number z is equal to negative 3 plus 2i. If we are to plot that one, or this one, so horizontal axis is for the real part, vertical axis is for the imaginary part. So when you observe, this time we have a negative real part. So let's say this segment is equal to 3, but on the negative real axis, that is negative 3, and a positive 2. So which means this one lies on the second quadrant. A is equal to negative 3, the value of b is equal to positive 2. So is this our argument? So take note, if we are to place the argument in our equation for the polar form z is equal to r multiplied by the quantity cosine of theta plus I sine of theta. The value of theta should be measured from the positive real axis, so not from the negative real axis. So let's say first, this is our theta 1. So our argument should be measured from the positive real axis. Usually, if it is measured counterclockwise, that should be positive theta. Alright? And if it is measured counterclockwise, it is negative. Okay? So counterclockwise positive, clockwise negative. So again, our basis should be on the real positive axis. Okay, that is the angle that are we going to use for the polar form of this complex number. So to determine theta 1, so we are to use absolute value for that one. That is, the tangent of theta 1 is equal to the absolute value of opposite, that is b divided by your adjacent a. So we have the tangent of theta 1 is equal to the absolute value of 2 over negative 3, but since absolute value, this is the same as 2 over 3. So what is our theta 1 equal to? That is a shift tangent of 2 over 3. We have 33 point. This is 33.69 degrees. How do we determine the actual argument? We have theta, and the value of theta is equal to, okay, we know this angle, this is a total of 180 degrees, okay, minus, okay, theta number 1. So we have theta is equal to 180 degrees minus 33.69 degrees. So we have the argument is now equal to, is 180 minus 33.69 is equal to 100. This is 146.31 degrees. This will be our argument. So if we are now to determine the value of r, that is the modulus, and the value of r is equal to the square root of, we have 2 squared plus the negative 3 squared. So the value of r, this is the square root of 4 plus 9, and the r is equal to the square root of 13. That will be the value of the modulus. Now if we are now to substitute, okay, we have the polar form z is equal to r, that is the square root of 13 multiplied by cosine of, what is our argument? 146.31 degrees plus I, that is the sine of, okay, 100. This is 146.31 degrees. So this will be our answer. Let's have another example. So, convert to polar form. We have the complex number z equal to negative 6 and negative 8. So, by the way, how do we determine the location or what quadrant this complex number lies? So, we have 4 quadrants again. So, this is if we have positive real part and a positive imaginary part, that is on the first quadrant. If we have negative real part and positive imaginary part, second quadrant, if both are negative, we have on the third quadrant, and if we have positive real part and negative imaginary part, that is on the fourth quadrant. Similar, if you are to compare this to the Cartesian coordinate system, x and y, okay, that is the coordinates in terms of coordinates x and y, similar to this one. So since we have negative 6 and negative 8, this will be on the third quadrant. So you have the value of A to be negative 6 and the value of B is equal to negative 8. So it will be over the plot of this a complex number. So again, if we are to determine the argument or the correct argument of a given complex number, if we are to convert this to polar form, it should be measured. The angle should be measured from the positive real axis. So let us first determine this angle. So I name it as theta 1. So we have that as the tangent of theta 1 is equal to the absolute value of b over a equal to the absolute value of negative 8 divided by negative 6. So we have the tangent of theta 1. We're using absolute value, okay, just to determine if we are to add or subtract later on. To determine the value of the argument to be used in our equation for the polar form of a given complex number. So it is the same as 4 over 3. So we have the value of theta 1 is equal to 53.13 degrees. So if the argument should be measured from the positive real axis, how do we compute for theta this time? The value of theta, so we know that this is 0, 90 degrees, 180. How do we compute for theta measured counterclockwise? That will be 180 degrees plus theta 1. So we have the value of theta is equal to 180 plus the 53.13 degrees. So we have the value of theta is equal to 233.13 degrees. This will be our argument. Okay, then we have the value of r, or the modulus. So we can have it by Pythagorean theorem, that is the square root of, or the absolute value z. We have negative 6 squared plus negative 8 squared. We have the value of r, this is the square root of 36 plus 64. We have the value of r is equal to 36 plus 64 is 100. Square root of 100 is 10. Then we substitute, we have z is equal to r multiplied by the cosine of theta plus I sine of theta. Okay, we have now z in polar form. That is r, that is 10. I multiplied by cosine of the argument. We have 233.13 degrees plus I. This is multiplied by sine of 233.13 degrees. And this will be our answer. The polar form of this complex number. The operations on complex numbers in polar form. So let's have multiplication. So first of all, we are looking for the product of z1 times z1 and z2. So we have z1 equal to 15 times the quantity cosine of 30 degrees plus I sine 30 degrees. Second, we have z2 equal to 3 times the quantity cosine of 10 plus I sine 10 degrees. So if we are to multiply two complex numbers in polar form, we are to determine the product of their modulus r, r1 times r2. Then, multiplied by the quantity cosine, we are going to add their angles. That is cosine of the argument of the first complex number plus the argument of the second complex number plus I. This is sine. Again, we are to add their angles, or the argument. That is z1, z2 is equal to r1, r2 times the quantity cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. So we have the product. What is our r1? That is 15. And multiplied by, this is 3. Multiplied by the quantity, this is the cosine of theta 1, this is 30 degrees, plus theta number 2 is 10 degrees, plus this is I sine of, our theta 1 is 30 degrees, plus theta 2 is 10 degrees. So we'll be having their product in polar form. This is 45, multiplied by the quantity of cosine 40 degrees, plus I sine of 40 degrees. So this will be the product of z1 and z2. So this is by multiplication. So how about division? So division of complex numbers in polar form. Let's say this is z1 over z2. This is the same as, we have to determine the product of their modulus. That is r1. I divide by r2, this is multiplied by the cosine of, we are going to subtract their angles. That is, this time theta 1 minus theta sub 2, okay, plus I sine of theta sub 1 minus theta sub 2. Okay, so we have now the quotient. R1 is 15. This is divided by 3. Multiplied by cosine of, we have 30 degrees minus 10 degrees plus I sine multiplied the sine of 30 degrees minus 10 degrees. So we have now the quotient of Z1 divided by Z2 is equal to 5 multiplied by the quantity. This is the cosine of 20 degrees plus I sine of 20 degrees. So this will be our answer. So by multiplication and division of complex numbers in polar form.